So we'll start. Now here we will study some multiple choice questions on simple harmonic motion. Now already we have seen number of multiple choice questions as well as theory on simple harmonic motion. Now here we will see some additional questions on simple pendulum and other some questions. So here first question is, the bob of simple pendulum of length L is displaced from the mean position to an angular position theta with respect to vertical. It is then released. The velocity at the equilibrium is, now A, root of 2gl in bracket 1 minus cos theta, B, root of 2gl, C, root of 2gl cos theta, and last one is root of 2gl in bracket 1 plus cos theta. So we have to find out velocity of the pendulum at the equilibrium position. Velocity of the here of the pendulum at equilibrium position. So what is given here? So if we see, suppose this is simple pendulum of length L and this is bob. So this one is what? This one is vertical axis. This one is vertical axis. Now what is given? L is length of the pendulum. So this is its mean position. Let us call this as O here. O. Now this bob is displaced from the mean position to an angular position theta. Means what happens? This bob is displaced like this. So bob is here and so this length is L and it is displaced through theta. It is displaced through theta. Now see here, if we draw perpendicular, so I will take this position as position A. This is equilibrium position, that is O. So perpendicular is drawn from this. Now with respect to this, the pendulum is displaced through vertical height h with respect to this equilibrium position, vertical height h. Now we know, suppose we have body of mass m, it is on the ground and m is mass. We know downward force is acting on the body, it is g, and if we displace this body in vertical direction and if we take this body here, work is done on the body. Suppose this height is h, then here potential energy, it is equal to mgh. mgh, mass, acceleration due to gravity, and height h through which it is displaced in upward direction. So at this position potential energy is this. So what happens here? At this position potential energy, it is equal to, now what is potential energy? mgh. mgh. Now when it is released, what happens? This one will oscillate. This one will oscillate. It will oscillate on this curved path and that is circular arc. So when it comes here, it is at equilibrium position. Equilibrium position. Now what happens? We know when oscillator comes from extreme position to equilibrium position, along the path its potential energy is converted into kinetic energy. Okay, it is converted into kinetic energy. Now we have to find here potential energy mgh. Now see here, this length it is L. So I will get this as L sin theta, and this part as L cos theta. So what is H? H is equal to, now this one, H is this one. Total length is L. So L minus L cos theta. That is H. So what is potential energy? Potential energy is mgl in bracket 1 minus cos theta. This is potential energy at point A. We have obtained this using geometry of the figure. L is total length. It is displaced through H, vertical height H. So we have to find this one. So this part it is L cos theta. Total is L. So H is equal to L minus L cos theta. Now what happens here? When means here from displaced position, when it comes at equilibrium position here, whole potential energy, it is converted into kinetic energy. So at equilibrium position, kinetic energy becomes what? Potential energy, because potential energy is converted into kinetic energy. So at O, kinetic energy is equal to mgl in bracket 1 minus cos theta. 1 minus cos theta. And we know kinetic energy is what? 1 half mv square. So 1 half mv square is equal to mgl in bracket 1 minus cos theta. Now this m will go. So v square is equal to what? 2gl 1 minus cos theta. So here, and v is what? Square root of that. So if we see here alternatives, out of 4 alternatives, if we see carefully, this first one is correct. This is correct. This is correct. Is it clear to you? Is it clear to you?
Yes, sir.
Yeah. Now next one. The period of simple pendulum is doubled when its length increases by 0.9 meter. What is its original length? Now we know here period of simple pendulum. Period of simple pendulum, it depends on its length only, and it is given as T is equal to 2 pi in square root L by G. G is acceleration due to gravity. Due to gravity. Acceleration due to gravity. Now what is given? The period of simple pendulum is doubled when its length increases by 0.9 meter. So I can see here T is proportional to root of L. So I can take T dash is proportional to root of L dash, where T dash is what? New period, L dash is new length. What is L dash? L dash is equal to length increases by 0.9 meter. So I can write L plus 0.9. That is new length. What is T dash? T dash, that is period of pendulum is doubled when its length increases by 0.9 meter. So when length is L plus 0.9, T dash corresponding period is 2 times T. So here we get T dash upon T is equal to root of L dash upon L. Proportionality constant is same, 2 pi upon root G. So we get here, we know 2T, T dash is 2T divided by T is equal to square root of L plus 0.9 upon L. So 2T upon T is 2. So 2 is equal to square root of L plus 0.9 upon L. So square on both sides. So on squaring we get 4 is equal to L plus 0.9 upon L. So we get here what? 4L is equal to L plus 0.9. L plus 0.9. So take this L here. We get what? 4L minus L. That is 3L is equal to 0.9 meter. So what is L? L is equal to 0.9 by 3 meter. So it comes out to be L is equal to 0.3 meter. So this is the original length. This is the original length, and new length is what? 0.3 plus 0.9, that is 1.2. So out of 4 alternatives, first one is incorrect, second one is incorrect, third one is incorrect, and last one D, that is correct. This is correct. So this is second problem. Now we'll go to third problem. Now what is given? A simple pendulum of length L and bob mass M is displaced from its equilibrium position O to position A so that height of A above O is h. It is then released. What is the tension in the string when the bob passes through the equilibrium position? A mg upon L, B 2 mg h upon L, C mg in bracket 1 plus h by L, D mg in bracket 1 plus 2h by L. Now here we have seen in first problem. Here we can displace bob from its equilibrium position to some point A through angle theta. So it is raised. It is raised from the equilibrium position by height h. So here same thing I will take here. So here bob of length, simple pendulum of length L. This is bob of mass M. Now it is displaced. So its position will be here now. Its position is here, and with respect to equilibrium position O, it is displaced through H. So what is potential energy here? It is potential energy will be equal to mgh. because here everywhere here it is downward force, that is mg. Here also downward force will be mg. Downward force will be mg. So now it is here at position A. And what is tension? Tension, it is along the length of wire and towards this fixed support. So I will call this as tension F. F is tension. It is along the string. Now what happens here? When we release it, it comes here. It comes here at this position. Now already at this position, due to gravity, downward force is mg. Downward force is mg. But here it is moving along circular arc. And when it comes here, it will have velocity here along this direction, means tangential to the path. Velocity tangential to the path. So what happens? We have one force, and now it is a circular arc of radius L. Radius L here about this point. I will call this as O dash. So let us take this as O dash. This is O. Now what happens? This is direction of tension along the string. This is direction of tension. There is already downward force mg due to gravity. But since it is moving and at point O there is velocity v, there is also one force, centrifugal force, that is mv square upon radius of circular path. Now radius is L. Radius is L. So what is total downward force? Total downward force at O is mg plus mv square upon L. This is total downward force, and this downward force is balanced by tension in the string. So I will take this as F. So this tension in the string, it is balanced by this total downward force at point O. So F is equal to mg plus mv square upon L. Now see here, potential energy at point A here, it is mgh, and this is extreme point. Extreme point. So when it comes here along this path, potential energy goes on converting into kinetic energy, and when it comes at the equilibrium position, whole potential energy is converted into kinetic energy. So at point O, kinetic energy mv square is equal to mgh. So what happens here? We get mv square. So it is equal to 2 mgh. 2 mgh. 2 mgh. 2 mgh. So here now, what is tension? So F is equal to mg plus mv square, that is 2 mgh by L. mv square upon L. This is centripetal force. So here we get F is equal to mg, I can take common, in bracket 1 plus 2 h by L. 2h by L. So this is tension in the string. This is tension in the string. At equilibrium position O. So here out of 4 alternatives, here this last one is correct. Mg in bracket 1 plus 2h upon L. Is it clear, Kirti? Pratiksha?
Yes, sir.
Okay. Now we'll go to next one. A block of mass 0.38 kg is kept at a rest on frictionless surface and attached to a wall with a spring of negligible mass. A bullet weighing 0.02 kg moving with the speed of 200 meter per second hits the block at time t equal to 0 and gets stuck to it. The displacement of the block in bracket in meter with respect to equilibrium position is given by A 2 sin phi ut, B cos 10t, C 0.4 cos 25 ut, D 0.25 sin 40 t. So what is given? So here now spring constant is given, that is 614 Newton per meter. So K is given. Now see here, this is block of mass. Let us take this as M, that is 0.38 kg, and it is at rest. So I will take this as equilibrium position. And spring has negligible mass. A bullet of weighing 0.25 kg moving with a speed of 200 meter per second hits the block at a time t equal to 0 and gets stuck to it. So what happens? This is bullet of mass what? 0.02 kg, and velocity, I can take velocity. Velocity is equal to 200 meter per second. So what happens here? When it incident on this at time t equal to 0, it stuck with it. Means what happens? New mass is what? This mass plus this mass. I will call that mass as m dash. So m is equal to 0.38 kg and m dash is equal to 0.02 kg. So resultant mass, that is m plus m dash, is equal to 0.4 kg now. Addition of these two. So what happens now? We have only one system now, and this system, it will start oscillating. Because it receives energy at equilibrium position. So that energy will be kinetic energy. So it receives energy. So what happens? This block will move along this direction. Then kinetic energy goes on converted into potential energy. Finally, whole kinetic energy is converted into potential energy, and then it will return. But mass is what? M plus m dash. So what is angular frequency? Omega is equal to under root k by m plus m dash. So what is omega now? So omega is equal to 640 divided by 0.4. Now 640 divided by 0.4. So here if we calculate this, we will get root of 6400 divided by 4. So omega is equal to under root 1600. Now 1600 means its square root is 40 radians per second. We got this. But we have to find equation of motion. What is equation of motion? X is equal to A sin omega t plus phi. Now what happens here? Since it starts from equilibrium position at t is equal to 0, so at t is equal to 0, what is x? X will be equal to 0. It starts from equilibrium position. So 0 is equal to a sine phi. So phi is equal to 0. Okay, starting phase is 0. So x is equal to a sine omega t. Out of that we got omega. Omega is 40 radians per second. We do not know a. We have to find a. So how can we find? We know dx by dt. Dx by dt, that is velocity. Velocity. And what is velocity? A omega cos omega t. A omega cos omega t. This is velocity. This is velocity. Now, what is velocity? So, what happens here? When this bullet, it stuck with this mass, it will transfer all of its energy to block. So what happens? We can apply conservation of momentum. So what is momentum of bullet? That is m dash into v. I can call v dash, and that one will be equal to m plus m dash into v. M dash v dash was momentum of bullet. That is initial momentum, and m is at rest. But when it strikes with mass m, bullet strike with mass m and stuck with it, its mass become m plus m dash and velocity will be v. So initial momentum will be equal to final momentum. So what is v? So v is equal to m dash upon m plus m dash into v dash. Now m dash we know it is 0.02 upon 0.4 into what is v? It is 200 v dash. Here we have taken v dash is I will call this as v dash. V dash is 200 meter per second. So calculate this. So if we calculate this, so it is now you will get 4 upon 0.4. This one into this one, that is 4. So you will get 10 meter per second. That is velocity. Velocity is 10 meter per second. So at the mean position, what is velocity? This is velocity at mean position. At mean position, velocity is maximum. That is a omega. So 10 into a into 40, because omega is 40. This is maximum velocity, and here this velocity will be at equilibrium position because it stuck the mass, bullet stuck that mass at equilibrium position. So what is a? A is equal to 10 by 40. So it comes out to be 0.25. Now use in this. So x is equal to 0.25 sine 40t. This is the answer. So this last one is correct. Actually, this was asked in IIT JAM examination. Now next one, we will go to next one. We will go to next one. Consider a particle of mass m following a trajectory given by x is equal to x0 cos omega 1t and y is equal to y0 sin omega 2t, where x0, y0, omega 1 and omega 2 are constants of appropriate dimensions. The force on the particle is A, central only if omega 1 is equal to omega 2. Central only if x0 is equal to y0 and omega 1 is equal to omega 2. Always central, and central only if x0 is equal to y0 and omega 1 is not equal to omega 2. Now we must know first what is central force. Suppose we take two-dimensional system, okay? Two-dimensional system, and suppose this is origin of coordinate system x, y, and suppose some particle of mass m, it is moving, suppose along this path like this, okay? Now force is acting on this mass, and suppose that force, it is directed towards the center, then that force is called central force. Central force. If it is directed like this, it is not central force. It must be directed towards the center. That force is called central force. So suppose we take here, this is position vector r. This mass here will have coordinates x, y. So what is r? R we can take x plus jy. So whatever force, it will be along r. That force is called central force. Now here, what is given? Consider a particle of mass m following a trajectory given by x equal to x0 cos omega 1 t. So this is periodic motion with angular frequency omega 1 and amplitude x0, and this is also harmonic motion along y-axis. So what happens here? Here again we have xy coordinate system, and suppose we take mass here, and if we displace this mass, so two simple harmonic motions will act. One will act along x-axis, another will act along y-axis. Now motion along this, it is given as, so due to these two motions, particle will move on xy plane, and we know force will act due to SHM on along x-axis, due to SHM along y-axis. We know x is equal to x0 cos omega 1 t, and what is dx by dt? Dx by dt, it is equal to x0 sin omega 1 t multiplied by omega 1, and what is d2x by dt square? I can take here minus omega 1 square x0 cos omega 1 t. So we get here d2x by dt square is equal to minus omega 1 square x. So this is simple harmonic motion because acceleration is proportional to displacement. Similarly, we can write y is equal to y0 sin omega 2t. So we get here dy by dt is equal to omega 2 y0 sin cos omega 2t, and d2y by dt square is equal to minus omega 2 square y0 sin omega 2t. So we get here d2y by dt square is equal to minus omega 2 square y. So this is also simple harmonic motion. Now suppose we take position vector r, that is xi plus yj. Now here we can take second order derivative d2r by dt square. This is acceleration, means here particle is moving along this path, and suppose r is radius vector at time t. So this is xy coordinate at time t. So we'll get what? I times d2x by dt square plus z times d2y by dt square. Now here we can write minus I. Now here omega 1 square x minus j omega 2 square y. So here d2r by dt square. Now see here d2r by dt square is not proportional to r because r is this. But if we take omega 1 is equal to omega 2, suppose we take. So if we take omega 1 is equal to omega 2, I will get minus I omega 1 square minus j omega 1 square y. So I can take omega 1 square common. So omega 1 square ix plus jy. So then we will get what? d2r by dt square is equal to minus omega square vector r. So here this is along r. Along r. So this force is central force only when omega 1 is equal to omega 2. So central only if omega 1 equal to omega 2. Now here central only if x0 is equal to y0 and omega 1 equal to omega 2. Here this is not required. What is required? This one is required. Always central? No. When omega 1 is not equal to omega 2, direction will not be along, direction of force will not be along r. And central only if x0 equal to y0 and omega 1 is not equal to omega 2. So omega 1 equal to omega 2 is required. So this first one is correct. Now we'll see last one. Now see here, if the length of simple pendulum is increased by 44%, then what is the change in the time period of pendulum? What is the change in the time period of pendulum? Now we have already seen period of simple pendulum t is equal to 2 pi under root L by G. Okay. Now we know t is proportional to root of L. So when L is increased, period is increased. Okay. So we can write here when L is increased, period increases. Period increases. So suppose L dash is new length. So new period is what? T dash is proportional to root of L dash. Now proportionality constant is this. So I can take here T dash upon T is equal to root of L dash upon root of L. So I can take this as root of L dash upon L. Now what is new length? If the length of simple pendulum is increased by 44%, means what is L dash? L dash is L plus 44% of L. 44% means I can write L plus 44 upon 100 into L. So length increases by 44%. So I can take here 1 plus 44 upon 100 multiplied by L. So T dash upon T is equal to square root of. Now see here, L dash is this divided by L. So LL will get cancelled. So you'll get what? 1 plus 44 upon 100. So we get here T dash upon T is equal to square root of 100 plus 44 divided by 100. So what is T dash upon T? So T dash upon T is equal to square root of 144 divided by 100. So square root of 144, it is 12 divided by 10. So I can write this as 120 divided by 100 also. So I can write this as 1 plus 20 upon 100. Okay, we can write like this. So you will get here T dash is equal to 1 plus 20 upon 100 whole multiplied by T. So T dash is equal to T plus 20 divided by 100 into T. So you will get T plus 20% of T. 20% of T. So period increases by 20%. So A 22%, B 20%. So this one is correct. This one is correct. This one is correct. So okay, हे समजले का तुम्हाला? संतोष कुंभार? Hello? Pratiksha?
Yes, sir.
Okay.
Yes,
Now we'll stop here. Tomorrow we will start with damped oscillations. So initially we'll cover some theory and then MCQs. Okay. So we'll stop here. And tomorrow we'll take damped oscillations. Okay. So thank you very much.